Hey everyone, today we'll be introducing the simple use of the ODOT CN8032. For this demo, we're using the Siemens S7-1200 DC. First, create a new project. Click OK. Once the project is created, click to open the project view. Next, click to add a new device. Expand the list and find our 1214 DC. Choose the corresponding PLC based on the order number. Then, click OK. And that's it. The project is set up. Once the project is created, click on Network View for network configuration. In the hardware directory on the right, find other field devices. Expand the list and select CN8032. Drag it into the configuration view. Click Assign to PLC. The PLC needs a unique name to connect to the network adapter. So now, let's set the device name. In the device section, find the network card for the adapter. Double-click to search for accessible devices. Our network adapter's dip switch is set to 2. You should see the CN8032 with the suffix -2. Select the network adapter. Now let's configure it based on the name we just found. Right-click on the module and choose Details. Uncheck Auto Assign IO Names. Manually change the IO name suffix to 2. Next, switch to the network topology view. Connect the PLC's network port to the module's port 1. And that's it, topology setup is done. Make sure the connections match the physical hardware exactly. If the PLC isn't connected to the correct hardware port, you'll get an error. If you only have one slave device, topology connections aren't necessary. But if you're working with multiple devices, it's better to set up topology connections. This ensures safety and reliable connections. Now, let's configure the modules. Double-click ODOT to start module configuration. We'll configure the following modules in order. 16-channel input, CT. 121F 16-channel output, CT. 222F 8-channel analog current out, CT. 4238. Make sure you select the correct modules. Incorrect configurations can cause PLC errors. For the CT 4238, right-click and open Properties to set the analog output type. You can choose either 0 to 20 milliamperes or 4 to 20 milliamperes. Here, we'll stick with the default 4 to 20 milliamperes. Once everything is set, click Save and download the configuration to the PLC. Click Search, then Download. Select Download without synchronization and click Stop all loads. Once done, click Complete and then go online. Now, let's check the PLC status. As you can see, the PLC and modules are running normally. Next, we'll write a program to test the input and output. The input address is IW2 and the output address is QW2. The analog output address is QW64. Open the main program to write the code. When I2.0 is on, it outputs to Q2.0. Then, use the move instruction to assign the value of MW100 to QW64. Download the program to the PLC for testing. Select Download without synchronization, then click Load. After that, click Complete. Go online and start monitoring. Now let's activate the PLC's inputs and outputs to check if everything is working correctly. You can see that when activated, the output lights up. We've tested it multiple times, and it's working perfectly. Next, let's input the decimal value 27648, which corresponds to 20 milliamperes for the analog output. We'll use a multimeter to measure the analog output by connecting it to the channel. Some slight errors in the reading are normal. As you can see, the analog output is displaying correctly. Now, let's write a value of 0. The analog output should now show 4 milliamperes. And as you can see, 4 milliamperes is displaying properly. Finally, we'll input -27648 to test again. Remember, 27648 is a decimal value. Don't enter the wrong format. You can see the output switches to 20 milliamperes. The output is functioning as expected. That wraps up today's demonstration. Thanks for watching, and see you next time.